Hi, this is Dr. Green. I want to talk to you a little bit about null hypothesis significance testing and how it works. Here we just want to hit the basics because you guys really don't have the conceptual background to understand this well, and it's going to be confusing when you first start out, but wait until you get farther along in the course and you will understand it more. So here's the basics. With null hypothesis significance testing, we want to answer a research question that can be formulated as a yes or a no. Some possible questions could be, does the new drug work better than placebo? So every time the FDA tests and approves a drug, they use null hypothesis significance testing. So they have a new drug and they test it on a group of people, and then they have another group of people, usually same size and same demographics, and they give them a placebo sugar pill. And then they see what happens. And that new drug has to work better than the placebo to get approved. Do airbags decrease traffic fatalities? Well, how do we make that decision? Well, we have to gather some data, and then we have to look at what happens with people that use airbags and have a traffic accident and people that do not use airbags and have a traffic accident. And then we'll analyze that data and try to decide whether or not it's due to chance. Or here's a little bit more on the silly side. Do eating M&Ms cause acne? So, maybe you've heard your parents say, well, when you were younger, don't eat too much chocolate, it causes acne. You're going to break out. So is that true? Yes or no? Well, we could test it with null hypothesis significance testing. Of course, all our conclusions are only going to be true for the appropriate population. So with our drug test there, say it's a diabetes drug, then our conclusions are only going to apply to people that have diabetes. Similarly, our airbag conclusion is only going to apply to people who drive cars for their mode of transportation. It's not going to apply to people that take the bus. And M&Ms causing acne? Well, our population is probably going to refer to teenagers and not senior citizens. So first we need to formulate something called a null hypothesis and an alternative hypothesis to make this hypothesis testing thing work, NHST. So our null hypothesis is the hypothesis that nothing happens, there's no effect of our treatment. And then the alternative hypothesis, also called the research hypothesis, is the hypothesis that something does happen. There is indeed an effect to whatever our treatment is. So for our example with the M&Ms, the null hypothesis would be that eating M&Ms does not cause acne. And then the alternative hypothesis would be eating M&Ms does cause acne. So notice that the null and alternative are opposites of each other because we're answering this yes or no question. So how do we come to a conclusion? Well, we're going to take samples and we're going to test our hypothesis on the samples. So we're going to select 50 individuals, probably teenagers, and we're going to have them eat M&Ms every day for a month. Okay, they're going to gorge on M&Ms. It's going to be wonderful. And then we're going to select another 50 individuals, probably teenagers again. Actually, we want our two groups to be the same in every way except for eating M&Ms. So we're going to select another 50 random individuals and we're going to instruct them, hey, don't eat M&Ms for a month because it's going to make you break out with acne. Okay, and that's what we're trying to test. And they're going to try and hold all the other variables constant. So we can't have our individuals that are eating M&Ms, they're also using a special antibacterial facial cleanser while the control group is not. Okay, that's not going to work. Otherwise, we can't make valid conclusions there. So what happens at the end of the month? Well, some possible outcomes would be the M&Ms group could have about the same amount of acne as the control group. So when that happens, it could just be due to chance. And our conclusion there would be that M&Ms do not cause acne, at least for the population we're interested in. Or it could be the case that the M&Ms group has a lot of acne, way more acne than the control group. And so much more that we just decide, hey, this cannot be due to chance. It has to be the M&Ms that are causing the acne. And that would be our conclusion, is that M&Ms do cause acne. And the way that we make that conclusion, really, we conclude that alternative hypothesis, that the M&Ms do cause acne, by concluding that the null hypothesis, the conclusion that they don't cause acne, is unlikely. So if you see a lot more acne in the M&Ms group here, you're going to say, oh man, the null hypothesis just can't be true. It's just highly unlikely. So we call that rejecting the null hypothesis. So the way that you accept the alternative hypothesis is by concluding that there's a very small chance that the null hypothesis is true. So that's NHST in a nutshell. Now, NHST is not perfect. It does have problems, but even the alternatives that are suggested to it also have problems. But you know what? The FDA has been using NHST to approve every drug that you've taken since they started approving drugs. And it's a very complex process. There's a lot of calculation that goes on, and that is something that I haven't showed you. But hopefully this gives you a general idea of what NHST does for us.